Welcome to qnawire.
Hi there. So for this problem, we are asked to find the diameter of a pipe. So we need to find the diameter and with a length that is given, and that length that we're going to call capital L is 2,000 meters. And also we are told that when the rate flow of water through the pipe, so the discharge is given, and that is 200 liters per second. We can also write in cubic meters per second as 0.2 cubic meters per second. We are also the heat loss due to friction is 4 meters. So the heat loss that we are called HF is 4 meters. And we need to take the value of C as chassis constant. C is going to be a value of just simply 50. So again, we need to find the diameter of the pipe. So we start by knowing that the volume can be written as the discharge divided by the area. Now, we can write the area in terms of the diameter as pi divided by 4 times the diameter square. So, with that said, in here, you can see that if we substitute the value for the discharge, so that will be 0.2, and this times 4, this divided by pi times the diameter to the square. So the hydraulic mean depth, we're gonna call it M, is equal to the diameter divided by 4. That is the hydraulic mean depth. Now, the loss of head per unit length, that we're gonna call I, is equal to HF, which is the head loss due to friction, divided by the length L. So that will be 4 divided by the 2,000 that we are given for the length L. So that will give us a value of 0.002. Now, chassis formula is given by the following equation that states that the volume is equal to chassis constant times the square root of the product between the hydraulic mean depth and the loss of head per unit length I, which we determined from before. So substituting the values of the volume M and I and C, we get the following. So we will get 0.2 times 4, then this divided by pi times the diameter squared, then this is equal to 50 times the square root of the diameter divided by 4, which is M. This times I, which is the loss of head per unit length that we determine is 0.002. Now what we need to do is to start solving for the diameter. So we can just simply start solving for that. So when we do that, when we we can elevate both sides to the square, and then we will obtain that the diameter to the phi is equal to a value of 0.0518. Then if we take the fifth root both sides of this expression, just like this, we obtain a diameter of 0.553 meters that we can also answer in millimeters as 553 millimeters. So that's the solution for this problem.